Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening, children. All right. So yesterday's class, okay, the last class we finished exercise 10.4 with that sixth question. Ankur, Syed, and David sitting on the boundary of a circular park, and playing with each other with the toy telephones. We had to find the length of the string of the toy telephones. Okay, so with that, we had come to the end of exercise 10.4. So this is the exercise 10.4, the example before exercise 10.5. We've completed exercise 10.4. So this is the example before 10.5. Yeah. So in the given figure, AB is a diameter of the circle. Excuse me. AB is a diameter of the circle. CD is a chord. CD is a chord equal to the radius of the circle. So the length of CD is equal to the radius of the circle. AC and BD, when extended, intersect at a point E. AC, you can see that AC and BD, when extended, intersect. So AC is a chord. BD is also a chord. The two chords do not meet inside the circle. They meet when they are produced. They meet outside the circle when produced. AC is a chord to the circle with center O. So is BD. BD is also a chord to the circle with center O. The chords AC and BD do not intersect within the circle. When they are produced, they meet outside the circle at E. We need to prove that angle AEB is equal to 60 degrees. So much of information we have. AB is a diameter. Keep that in mind. Whenever the diameter is mentioned, immediately angle in a semicircle is a right angle. Maybe you have to use that property. See, because that property can be used only when only when one of the diameters is known to us. If you do not know the diameter of the circle, then you cannot use a property. Angle in a semicircle is a right angle. So this property or this theorem, angle in a semicircle is a right angle, can be used only when you know a diameter of the circle. So here we have AB diameter. So maybe sometime we have to use this theorem. Angle in a semicircle is a right angle. CD is a chord, and the speciality is its length is equal to the radius of the circle. Okay. So again, we have something is conveyed there. We'll see what. And then AC and BD, they're chords. It's not mentioned there, but we can make out that they are chords. AC and BD are chords, and they intersect when they are produced at this point E. Prove that AEB is 60 degrees. Okay. So let me just help you with the construction. After that, you have to tell me how to. So prove that, meaning we'll have to find the measure of angle AEB. We'll have to get the answer as 60 degrees. So we prove that AEB is 60 degrees. Am I clear, children? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. All right, children. So the construction, I'll tell you why. The construction is we somehow have to make this, we have CD equal to the radius. So we have to join, we have CD, a chord whose length is equal to the radius of the circle. So what we do is, we join two more radii, so that the triangle becomes an equilateral triangle. See, let's see what happens when we join OC, because CD is the chord, right? So let's join. You have to join from the center. To get the radius, you'll have to join from the center. So let's join OC and OD. Let's join OC and OD. Okay, so let's join OC and OD. OC and OD. So now what happens, the triangle OCD or triangle COD is an equilateral triangle because OC is a radius, OD is a radius, CD is not the radius, but its length is equal to the radius. Supposing the radius is 6, then this is also 6. CD is not the radius, CD is a chord, it's not the radius, but its length is equal to the radius of the circle. So if the radius is 6, 6, 6. So COD is an equilateral triangle. Why should we get an equilateral triangle? Because see, there is no angle in this figure. And how can you find AB? So when you have an equilateral triangle, we know each angle in an equilateral triangle measures 60 degrees. So that will be useful for us. That's what it is. So we join, why join OC and OD? Because CD is the chord, CD is the chord, OC radius, OD radius. So that makes OCD an equilateral triangle. And so, some angles crop in. Okay. Okay, so let's join OC. And now tell me, what should we join in order to use the property angle in a semicircle is a right angle? AB is the diameter.
CB.
Sorry? Louder?
BC.
CB.
BC.
CB, ma'am.
BC.
Yes,
BC
ma'am.
should be joined because AB is the diameter. AB, AB is a diameter. AB is the diameter. So A, you can see the point C on the circumference and you can see AC. AC. So we'll join BC. So we will join BC. Just a minute, children. Why Pranav is not able to join the meeting?
Ma'am, you have sent some pictures, ma'am. Should we write it?
No, I'll tell you. I'll just give you that instruction.
Okay.
Yeah, in some time. I shared my screen by mistake. Have I shared my screen again?
Yes, ma'am.
Okay.
Yes, ma'am.
All right, children. Yeah, so we were saying join OC, OD, and
BC.
yeah, BC. BC. And so now you have the reasons, okay? You have the reasons as to why we should do these constructions. Now, which angle is 90 degrees?
Angle ACB, ma'am.
ACB is 90 degrees. This angle is 90. This angle is 90. So now if ACB is 90, which is that other angle which is 90 degrees?
Sorry, ma'am, what?
If ACB is 90, use linear pair and find some other angle which is 90 degrees.
BC.
D.
BCE.
BCE. BCE. See here, I'll show you. Now, this is the, there is, okay. There's something like this. B. So we say ACB. Can we see that? ACB is 90 degrees. This is 90 degrees. ACB is 90 degrees. So linear pair axiom, this angle also will be 90. BCE. BCE. BC, this one is 90 degrees. BCE is 90 degrees. Here, I've shown it here. ACB is 90. Angle in a semicircle is a right angle. So BCE is also 90 degrees. Okay, so that is one part. Now, each angle of this triangle is 60 degrees. So this angle is 60, right? This angle is 60 degrees because each angle in an equilateral triangle measures 60 degrees. So this is 60. And so that means angle COD is 60 degrees. Which arc subtends angle COD? Which arc? Which arc subtends COD?
CD, ma'am.
Arc CD. Arc CD subtends angle COD where on the circumference or at the center?
At
The
center, ma'am.
circumference. Oh, sorry, ma'am. Center.
Center. Arc CD subtends angle COD at the center of the circle. Now identify an angle made by the same arc CD. You can make out from the name, the way you name the angle. So there should be CD and some other letter here on the circumference. Which are the letters on the circumference you have? No.
A, B.
A and B, right? You only have A and B. So just try to put A here and B here. Just try to put A and B
C,
here.
CAD and CBD, ma'am.
Yeah, but can you see the angle CBD here? CBD, this one.
Yes, ma'am.
Yeah. So since COD is 60 degrees, arc CD subtends angle COD at the center. And COD is 60 degrees because COD is an equilateral triangle. The same arc CD subtends angle CBD on the circumference. CBD on the circumference. So CBD is equal to how much? COD is equal to CBD, right? Children, what will be the measure of angle CBD? COD and CBD are subtended by the same arc CD at the center O and on the
60
circumference at B. What is the measure of angle CBD?
60 degree, ma'am.
Who's that 60? Nivedita?
Yes, ma'am.
Okay, Nivedita. Okay. Yes. What about the others in the meeting? What is the measure of angle CBD? Hitesh, Ananya, Deepika, Kanishka, Arav, Nikita, Nivedita, Pratiksha, Satvika, Shreyas, Tarun. What is the measure of angle CBD? If COD is 60 degrees, how much is CBD?
60, ma'am.
I should say I am disappointed. We've all got 5 and 6 in the exam, in the test on circles. If this is the knowledge we have, then I wonder now how we scored 5 on 6, 6 on 6. If COD is 60 degrees, how much is CBD?
60 degree, ma'am.
Kanishka, is it?
Yes, ma'am. Actually, I went out. Oh, sorry, ma'am.
Okay. Okay, so at least I don't know if the others have the correct answer in their mind, but at least those who shared it, I'm happy that, you know, people who share, I'm always thankful to you because you're the ones who keep the class going. Otherwise, otherwise I'll have only one choice. I'll just do my duty and keep moving. So, yes, so, you know, as always, Kanishka, Shreyas, Pratiksha, Nivedita, these children, they participate. Shreyas is very active, always. Kanishka, if she's in the meeting, she's active. Hitesh was, I don't know, I'm disappointed why he isn't now. Others don't want to share their answer, you know, because I don't know why.
Ma'am, CBD 30 degree.
Who's that?
Hitesh.
Hitesh. So you were hibernating, is it? Just came out of hibernation?
No.
You're right. CBD is 30 degrees. Why, Hitesh? Why, Hitesh?
I thought angle B will be 90 minus 60 is 30, so set it as 30.
Oh my, no. Okay, children. So the angle subtended by an arc at the center is double the angle subtended by the same arc at any point on the remaining part of the circle. So if the angle at the center is 60 degrees, the angle formed on the circumference by the same arc will be half of it, 30 degrees. So CBD will be 30 degrees. CBD is 30 degrees. This is 30 degrees. COD is 60 degrees. CBD will be 30 degrees because it's subtended by the because the angles are subtended by the same arc CD, one at the center O and one on the circumference at B. The angle on the angle formed on the circumference is half of the angle formed at the center. The circumference will be 30 degrees. The angle formed on the remaining part of the circle will be 30 degrees. Now you can see the triangle BCE. You can see the triangle BCE. Okay. You can see the triangle BCE, wherein you know that this is 90 degrees and you know that this is 30 degrees. So by angle sum property, this one is 60 degrees. By angle sum property, this is 60 degrees. So we proved that AEB, if this is 60, see, we proved that this is 60, or we found that this is 60 degrees. This one is 60. This is CEB, or it's also AEB. It's this angle can be, this angle you can call it by different names. You can call it CED, CEB, AEB, AED. This angle can be called by, many names. You can call it CED, CEB, AED, so AEB. So this angle is 60 degrees. This angle is 60 degrees. So which means angle AEB is equal to 60 degrees. So construction, join OC, construction, join OC and OD, construction. That makes COD an equilateral triangle because this is equal to the radius. This is R, this is R, this is also R. All the three sides are equal. So it's an equilateral triangle. So this angle is 60 degrees. Now we also understood that we have to join BC. We'll have to join BC so that we can use the property angle in a semicircle as a right angle. Now see this arc CD. It makes COD at the center. Arc CD makes COD at the center. The same arc CD makes CD makes angle CBD. CBD. The same arc makes CBD. Arc CD makes COD. You can make out from the way you name the angle COD, CBD. So this one is 30 degrees because it's on the circumference. Half of the angle is the center. So this one is 30 degrees, CBD. See this one is 30 degrees. And then this is 90. Angle in a semicircle is a right angle. So linear pair, this is 90. Now in triangle CEB, because you have the angles in those triangles. See here, you have this angle and this angle. These two angles are angles of triangle CEB. triangle CEB, we know two angles. We know 30 degrees and 90 degrees. So you can find the third angle. By angle sum property, this third angle is 60 degrees. So that means AEB is 60 degrees. Please write down. Please work it now in the class. NCRT example 3. NCRT example 3. All of you have to submit today's classwork. So since I was not regular in posting, the list of students who submit their classwork, you probably had a doubt if you have to share the pictures or no. Please share your pictures regularly. Please share your pictures regularly. So today's class, at the end of today's class, share the pictures of your classwork. I'll put up the list. Draw the figure. Children, personal excuse. I have some guests at home and they're leaving now around 8:15. I just need to engage them, I need to be there, which is why I've shared some questions on WhatsApp. Please, okay, ma'am. Yeah, please work them. Please work them. Let me tell you one by one. Take a screenshot of this. Complete this in your classwork.
Okay, ma'am.
Please take a screenshot.
Yeah, took, ma'am.
All of you. Thank you, Kanishka. All of you. Done?
Yes, ma'am.
Yes, ma'am.
Okay. This one, children, this is definitely easy to understand. You don't need my help. This one. Complete these two in your classwork and then try. I've shared 4 questions. So try them. Please write the question and try to get the answer. Try them. I'll get back to you by 8:20.
Okay, ma'am.
Yeah, please work example 3 in your classwork. Example 4.
Okay, ma'am.
Yeah. And then try those 4 questions which I've shared on WhatsApp with you. I'll get back by 8:20, children, which is why I couldn't do the class in the morning also. And then
Okay,
I
ma'am.
can make it from 7 to 8:30, and that also became difficult. So now I have to excuse myself because they're leaving. Thank you so much, children.
Okay, ma'am, no problem.
Thank you. Thank you. I'll just put myself on mute. Do your work.
Okay, ma'am.
Yeah. Thank you. Yeah, children, I'm done. I'm back. Thank you. So what's the status? Have you tried at least the first three questions?
Yes, ma'am.
Okay, that's good.
Yes, ma'am.
That's good. Let's discuss example 4. In example 4, we are given that, or we can see that ABCD is a cyclic quadrilateral. We can see that ABCD is a cyclic quadrilateral because the vertices A, B, C, and D lie on the circle. It's also given that AC and BD are its diagonals. That we know AC and BD are diagonals, they are not diameters. It's not given that they're diameters, that's just diagonals. AC and BD are diagonals of ABCD. That's 55 degrees. DBC, DBC, this is 55. This is 55. And BAC, BAC, this is 45. 45 degrees. Find BCD, 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 this one. BC triangle. This one is an angle of, you can again do it in 2-3 ways. So which is this angle. So I don't know how it is worked here, but let me just tell you what I have in my mind now. So if this angle is 45 degrees, children, if this is 45, this is also 45 because BAC, BDC, BAC on the circumference at A, BDC on the circumference at D. And the theorem is angles in the same segment of a circle are equal. So this will be 45 degrees. No, I told you, I don't know how I worked here because you can do it in 2-3 ways. So what I'm telling you now is angle BAC is equal to BDC. Angle BAC is equal to angle BDC. Angle BAC is equal to BDC because their angles, they're subtended by the same arc BC at the points A and D on the circumference. BAC is equal to BDC. Angles in the same segment of a circle are equal. And then, as I told you, that this one is an angle of triangle BCD. So using angle sum property, you can find the measure of this angle. You can find the measure of this angle using angle sum property. 55 plus 45 is 100, and so this will be 80 degrees. What did we do now? What did we do now? DBC. DBC is 55. BAC, this is 45. So we said BAC is 45, so BDC is also 45. BDC is also 45. And then in triangle BCD, we know this angle, we know this angle. So the third angle BCD is 80 degrees. 55 plus 45 is 100. 180 minus 100 is 80. Now what is it here? DAC is equal to DBC. Okay, so they've used this angle. I mean, I've used this angle first. DBCD. Yeah. We've started with 55 degrees first. So what I explained, I started with 45 degrees first. I started with 45 degrees. This is 45, so this angle is also 45. So here I've started with 55 degrees. So if DBC is 55, then DAC is also 55. This is 45. If DBC, DAC, BC, DAC are made by the same arc DC at the points B and A on the circumference of the circle. So this says the meaning with this we can say that angles in the same segment of a circle are equal because they're subtended by the same arc DC at two different points B and A on the remaining part of the circle. DBC, DAC made by the arc DC at the points B and A on the circle. So if DBC is 55 degrees, if DBC is 55 degrees, Then DAC, DBC, DAC. This is also 55 degrees. This is 55 degrees. So now this full angle is 55 plus 45, 100 degrees. Opposite angles are supplementary in a cyclic quadrilateral. So this is the 80 degrees. So that's what you see here. That's what you see here. This is 45. This is 55. So angles in the same segment of a circle are equal. So this is 55. DBC, DAC. So now this full angle is 100. Opposite angle is supplementary. So this is the 80. Yes, children, what's the answer to this question? A chord of length 24 centimeters is at a distance of 5 centimeters from the center of the circle. Calculate the radius of the circle.
Ma'am, I have got 13.
13, no? The radius
got 13 centimeter.
13. Okay. So the first thing is we have to incorporate all this information in a circle. So let's do that. So circle, a chord of length 24 centimeters. So let AB be a chord of length 24 centimeters. It's at a distance of 5 centimeters from the center. Distance is always perpendicular distance. So the chord is at a distance of 5 centimeters from the center. The chord is at a distance of 5 centimeters from the center. Distance always means perpendicular distance. So you can see the angle, meaning perpendicular marked here like this, indicating it's 90 degrees. Angle O, okay, this angle, since I've not marked this, let me call this M. Angle OMA is equal to OMB is equal to 90 degrees. Calculate the radius of the circle. So radius is, you can either join OA or join OB, any one. You just need a triangle. You can either join OA to find the radius OA, or you can join OB where the radius is OB. Any one of the two. So if you join OA, now we need to know, to find OA, we need to find the radius. So we need to know the remaining two sides of the right triangle. OM is 5 meters. And we know that a perpendicular from the center to the chord bisects the chord. So 24 will become 12 here and 12 here. Because OM is perpendicular to AB. Now you'll ask me, you drew it perpendicular to AB. It was not given that it's perpendicular to AB. It's given it's at a distance of 5 centimeters from the center. And when you show the distance, it's always perpendicular distance. So 5 centimeters is the perpendicular distance. So OM is perpendicular to AB. That 5 centimeters, the chord is at a distance of 5 centimeters from the center. Distance is perpendicular distance. So OM is perpendicular to AB. OM is the distance. OM is a perpendicular distance of the chord AB from the center. And again, another theorem, the perpendicular from the center to the chord bisects the chord. So AM, so M is the midpoint of AB. M is the midpoint of AB. So AM is 12 centimeters and MB is 12 centimeters. So now in triangle AMO, which is a right triangle, we know two sides, 12 centimeters and 5 centimeters. So by Pythagoras theorem, OA is equal to 13 centimeters, or the radius of the circle is 13 centimeters. How much is OP, children? How much is OP?
5, ma'am.
5 centimeters. How much is AB?
24 centimeter. 24 centimeter, ma'am.
24 centimeters. What about AP?
12
12
centimeters.
centimeter, ma'am.
PB?
12 centimeter, ma'am.
12
What is-
centimeters.
What is the theorem? The perpendicular, repeat, the perpendicular from the center to the chord bisects the chord. The perpendicular?
From the chord bisects the chord, ma'am.
No, the perpendicular
From the center of from the center to a chord bisects the chord.
Very good. The perpendicular from the center to a chord bisects the chord. So P is the midpoint of AB. So that makes AP, PB each equal to 12 centimeters. So OA by Pythagoras theorem is 13, or the radius is 13. So what's the diameter of the circle? For the same question, if they ask you to calculate the diameter of the circle, you'll have to first find the radius and double it to get the diameter. For the same question, if it is calculate the diameter of the circle, you should find the radius OA and double it to get the diameter, 26 centimeter. If you have not completed this, please take a screenshot, children. Complete this. What's the answer for this one?
Ma'am, is it 24 centimeters?
Yes, ma'am. Even I got the same answer.
Okay, let's see. So circle. In a circle of radius 26 centimeters. See, whenever you see a question involving, these information, radius, length of chord, distance from the center, so draw a figure like this. The information given here can be incorporated in a figure like this. When you see length of chord, radius, find the distance from the center. So this is the figure where AB is the length of the chord. OP is the distance. OP is the perpendicular distance of the chord from the center, and OB is the radius. We can see 3 line segments in this figure. Apart from the circle, we can see 3 line segments. One is AB. Okay, you can. I'm talking about these 3 line segments. AB. See, you find AP and PB also. AP and PB. I'm talking about AB. One AB, the other OP, and the other OB. So the line segment AB is the length of the chord. The line segment OP is the perpendicular distance of the chord from the center. And the line segment OB is the radius. So when you have information like this regarding the radius, length of chord, distance from center, draw a figure like this and write down the details in this figure. In a circle of radius 26 centimeters. So this is 26. A chord of length 20 centimeters. The chord from A to B, is 20. So this will be 10 and this will be 10. Because a chord of length, the length of the chord is from A to B. But for this triangle, you need only PB. For this triangle, you need only PB. You don't want AB. You want only PB for this triangle. So use the theorem. The perpendicular from the center to a chord bisects the chord. So 10 centimeters, 10 centimeters. Find the distance of the chord from the center. This is what we'll have to find. Find the distance of the chord from the center. Find the distance of the chord from the center. OP. OP is what we have to find. So Pythagoras theorem, 676 minus 100, 576, square root of 576, 24 centimeters. Did Shreyas and Kanishka give me this answer, 24 centimeters?
Yes, ma'am, I got 24 centimeters.
Okay, fine, that's right.
Yes, ma'am, I too got the same. Ma'am.
Okay, very good, very good. That's right. Yeah, these are the steps, children. Take a screenshot. Find the length of the chord of a circle of diameter 34 centimeters, which is at a distance of 8 centimeters from the center of the circle. What's the answer for this one?
Ma'am, I got it as 30 centimeters.
30, is it?
Yes, ma'am.
Yes, ma'am.
Yeah, just a second, children, just a second. Yeah, children. Yes, Shreyas, what's your answer? I think you shared your answer. Somebody told me
Yes, ma'am, 30
30.
centimeters.
30, 30. Okay. So here let's find the length of the chord of a circle of diameter 34 centimeters. Diameter is 34. So let's draw a figure like this. You should find the length of the chord. Okay, diameter 34. So what OB is the radius. OB is the radius. So 17. Which is at a distance of 8 centimeters. So OP is 8 from the center. So this will be 17 square is 289 minus 8 square is 64. So that gives us 225 and the square root of 225 is 15. So PB is 15. PB is 15. Then AP is also 15. So the length of the chord AB is equal to 15 plus 15, 30 centimeters. So you're right, both of you. Shreyas and Kanishka, very good. Diameter is 34 centimeters, so the radius is 17. The distance of the chord from the center is 8 centimeters. So by Pythagoras theorem, we get AP is 15 centimeters. If AP is 15, PB is also 15 centimeters. So the length of the chord AB is 15 plus 15, 30 centimeters. Take the screenshot, children. Class, use the emoji, raise your hand. Kanishka, Deepika, Nikita, Pranav, Ananya, Satvika, Shreyas, Pratiksha, Arab. Tarun, Ishwaran, Tarun and Hitesh. All right. What was the next one, children? Fourth one.
Actually, I have a doubt in this one, so I wasn't able to complete.
Okay. Okay, let's do it together.
The same.
Yeah, Shreyas?
I do have many doubts in this question.
Correct. Okay, let's see. Let's do it together. In a circle of radius 5 centimeters, PQ and RS are two parallel chords of lengths 8 centimeters and 6 centimeters respectively. So, circle. Now, when we have two parallel chords given here, but we don't know if the two parallel chords are on the same side of the center or on the opposite sides of the center. So that's why you have to calculate the distance between the two chords. In the first case, when they are on the same side of the center, other case where they're on the opposite sides of the center. So let's do the first case, same side of the center. So this is the center of the circle. Now, say both of them are like this and like this. I've told you that the perpendicular bisectors of the parallel chords will coincide. The perpendicular bisectors of the parallel chords will coincide. I've told you when we had a question or we had a situation like this. Given an arc of a circle, complete the circle. So there we had to take two chords, construct their perpendicular bisectors and all that. So during that time, I told you that when you take two parallel chords and construct their perpendicular bisectors, the lines will coincide. The perpendicular bisectors of two non-parallel chords will intersect. Now, if you take this one and this one, these are not parallel chords. So their perpendicular bisectors will intersect at the center. But when the chords are parallel, their perpendicular bisectors will coincide. They'll coincide. Their perpendicular bisectors will coincide. They'll pass through the center because the perpendicular bisectors will pass through the center. They'll coincide. So that means the perpendicular bisector of this one and the perpendicular bisector of this one is the same line. Circle, parallel chords, center of the circle on the same side. Now these two parallel chords are on the same side of the center. Radius 5 centimeters. So see here, from the center, this is the radius 5 centimeters. From the center, this is the radius 5 centimeters. See here, from the center, yes.
Ma'am, I have network issue, ma'am. Due to network issue, I went out, ma'am. You can show the before slide, ma'am.
Sure.
Thank you, ma'am.
Yeah. So when you join the center to this point, radius, center to this point, radius. Now this will be the perpendicular distance of this chord from the center. Continue that will be the perpendicular distance of the second chord from the center. So you must draw a figure like this. You can also do it like this. You can also take the two parallel chords like this here, like this. Center of the circle, radius, perpendicular distance from the center, So if you name, it's given PQ and RS, right? The longer chord will be closer to the center. So PQ will be closer to the center. RS, PQ, RS. Okay. So PQ is PQ is 8 centimeters. If we call these points M and N, 1 second, children. Yeah. So PQ chord, RS chord. Longer chord closer to the center. So PQ is 8 centimeters, RS is 6 centimeters. So PQ will be closer to the center because it's 8 centimeters. It will be closer to the center. So you can see it. OM is the perpendicular distance of the chord PQ from the center. ON is the perpendicular distance of the chord RS from the center. OP radius, OR radius. Who can repeat this information? What is PQ? PQ
It's a parallel chord. It's a chord, ma'am.
is a chord. RS?
It's also a chord, ma'am.
Why is Can we exchange the positions of PQ and RS? Can I mark PQ as RS and RS as PQ?
No, ma'am.
Why?
It's because the lengths are different, ma'am.
Correct. So can I draw a figure like this? Is this correct?
No, ma'am.
Why?
Miss, because PQ length is greater than RS, ma'am.
Correct. Because PQ is longer than RS. PQ is longer than RS, so it will be closer to the center. Okay. So, and then what is, name the two radii in this figure?
OP and ON, ma'am.
OP and?
Sorry, ma'am. OR.
OP and OR. How will you describe OM?
Sorry, ma'am. What?
How will you describe OM?
Perpendicular bisector, ma'am.
No. That's right. It's a perpendicular bisector. Okay, it's a perpendicular bisector of?
PQ and RS, ma'am.
No, what is OM? How will you explain?
OM, ma'am.
OM, yeah, MM.
A perpendicular bisector of PQ, ma'am.
No, something else. Class.
Height of triangle OPM, ma'am.
No, 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 no. No, no. You must use some phrases which we commonly use in circles. Class. Should I call out to somebody? Pratiksha? Can you hear me, Pratiksha? Pratiksha? Satvika? Ananya? Nobody has an answer? Nikita? My question is very simple. How will you describe the line segment OM?
Altitude.
No. All of you don't have to unmute and say, but please repeat this after me. OM is the perpendicular distance of the chord PQ from the center. Don't unmute. Repeat along with me. OM. You must be saying OM in your house there. OM is the perpendicular distance of the chord PQ from the center O. Now tell me, what is ON?
ON is the perpendicular distance from the center to the chord R.
Okay. So ON is the perpendicular distance of the chord RS from the center O. Very good. And now, are the chords lying on the same side of the center or opposite sides of the center?
The same side of the
Same side of the center.
Same side of the center. Now let's fill in the details given. Radius is 5. So can I mark OP 5 and OR 5?
Yes, ma'am.
Okay. And then how much is PM?
4, ma'am.
4. How much is RN?
3, ma'am.
3. Now take up the right triangle OPM. OPM. Using Pythagoras theorem, you can find the length of which line segment?
OM, ma'am.
OM. So we'll find OM. Then take the other right triangle ORN. ORN. Using Pythagoras theorem, you can find the length of which line segment?
ON, ma'am.
ON. Now what is the question? Find the distance between the two chords. Now this is the distance between the two chords, right? This is the distance between the two chords. This one is the distance between the two chords.
Okay,
The distance
ma'am.
between the two chords is ON minus OM. See, like you, 1 minute, I'll show you. This is O, this is M, this is N. This is the distance between the two chords. So that's nothing but ON minus OM. From ON, if you take away OM, you will get MN, which is the distance between the two chords. So how much is ON? You will get something for ON and then something for OM. ON minus OM is the distance between the two chords. And they lie on the same side of the center. When they lie on the opposite sides of the center, so one chord is here, the other chord is here. Center O, radius, radius. And this is the distance of, say, chord. This one is small, no? So I'll call it RS. I'll call this PQ. Let me do it again. 1 minute. It's correct, but I just want to do it again. Circle, radius, radius, radius PQ. You see it looks longer, no? And radius RS. 8 and 6. Now center O. Join OR, radius, and drop the perpendicular from the center to the chord. OM is the perpendicular from the center to the chord. Similarly here, join the radius OP and drop a perpendicular from the center to the chord. Drop the perpendicular from the center to the chord and let's call it ON. ON is the perpendicular. ON is the perpendicular distance, or it's a perpendicular from the center to the chord. ON is the perpendicular distance of the chord PQ from the center. Now tell me, and MON will coincide, meaning MON is a straight line. MON is a straight line because the perpendicular bisectors of two parallel chords will coincide. Because the perpendicular bisectors of two parallel chords will coincide. So MON is a straight line. Now tell me what is I don't want the answer, but which line segment represents the distance between the two chords?
MN, ma'am.
MN. So how will we find MN? MN is equal to
OM plus ON, ma'am.
OM plus ON. Very good. OM plus ON. The distance between the two chords is MN. And to find MN, we have to find MO from one right triangle, ON from the other right triangle, and add both to find the distance between the two parallel chords. So radius is 5. Radius is 5. And then RS will be half of 6, so 3. This is half of 8, which is 4. So 5, 4, you will get 3 here. by Pythagoras theorem. 3, 5, you will get 4 here. So the distance between the two cards is 4 plus 3, 7 centimeters. 7 centimeters. So when they're on the same sides, not same side of the center, you'll have to subtract. Opposite sides of the center, add. Take a picture, children.
Took, ma'am.
Okay. So some of us who tried this said you had some questions, right? Are your doubts clarified?
Yes, ma'am.
Okay, good. Shreyas, you too said you have some
Yes,
doubts regarding this.
Yes, ma'am,
Clarified?
I got clarified.
Okay, good. This is the second one. When they are on the when the chords are on the opposite sides of the center. Longer the chord, shorter its distance from the center. If the chord is long, it will lie closer to the center, so the distance from the center will be small. Just giving you, you can see here why the figure is made like this. So PQ is a longer chord. PQ is a longer chord. So OA, see, OA is a perpendicular distance from the center. It's very small. RS is relatively shorter, the shorter chord. So RS is shorter, which means its distance from the center will be longer. OB is more than OA. That's not going to affect your answer. If you make the figure a little different, that's not going to affect your answer. I'm just telling you, longer the chord, shorter is its distance from the center. Longer the chord, shorter is its distance from the center. Shorter the chord, longer is its perpendicular distance from the center. Yes. I'll show you both the slides again. This is the first one. When the two chords are on the same side of the center. This is when chords are on the opposite side of the center. All right, children. Just hold on. Oh, I had only 4 questions, right?
Yes, ma'am.
Yes, ma'am.
Done. We are done. Okay, okay. Just trying to find the 5th question. Okay. All right, children, then. That's it for today's session. Thank you so much. If you have any questions, please stay back.
Thank you, ma'am.
Good night, children.
Thank you, ma'am.
Thank you, ma'am.
Thank you, children. Good night.
Thank you.
Thank you. Good night.